Should we start? Okay. Before I ended the first part, I was going to provide you the solution of why the sun appears to you bigger during the sunrise or during the sunset, right? Now, what do you mean by sunrise? That is sunrise. Yes, that is the most correct version, that it is coming just above the horizon, then we call it as a sunrise. But before sunrise, we are having either a dawn or a dusk. If I talk in terms of rise and setting, there is a dawn or a dusk. It is a time for which the sun is not in the sky, but we are able to get the light. Getting me clearly? Now, before the sunrise, the situation would appear to you somewhat like this. Suppose this is the earth. This is representing the atmosphere around the earth. This is a horizontal line which is representing to us the horizon. And sun is present here below the horizon. I don't ask the question that how we are showing the sun to be smaller. It is from the point of view that we are looking from the earth, we feel sun to be smaller. Right? Perception is there. So that part is clear. Otherwise, you will think that sun is smaller and earth is bigger. That's not the case. Sun is there below the horizon, but the rays of light of the sun will be coming from here and just striking the atmosphere. So I'll be showing there's the rays of light striking the atmosphere here. Like this. From the other side too, the ray of light will be coming here and striking here. Okay? So they are striking the atmosphere. They are traveling from vacuum to this part which is containing air. So there is a light traveling from rarer to the denser medium. So when it is traveling from rarer to denser, it will bend towards the normal. Now, how to plot a normal? So, from the center of Earth to the point where the light is incident, you will be drawing the line along the radius of the Earth. Similarly, you will be drawing the line along the radius of the Earth to this particular point. That will be normal to that particular surface of Earth as well as to the light where the light is incident. Okay? Now, the ray will be bending towards the normal, so you will be able to see that the ray is bending towards the normal. Here also the ray will be bending towards the normal. Okay? Able to get this? Now, according to the first principle, that light travels in a straight line. So if I extend these lines in a backward direction, I am able to get the shape of the sun appearing to me like this. It's much more bigger as compared to the shape shown below the horizon. So on account of refraction, you are able to see that there is a size of the sun which appears to you bigger than the actual size. During the midday, what happens? The sun rays are directly coming to us. So angle of incidence will be? So no refraction takes place. As no refraction takes place, you are able to see the actual size of the sun. Able to get the reason for that? About the twinkling of stars, how many of you have seen the stars? This is really a big question. नहीं देखा है. If you have not seen the stars, what is the use of this life? So again, I am reframing the question, answer it. How many of you have seen the twinkling stars? Have you really seen the twinkling stars? Say. You will find that all the stars will never twinkle. If you have seen every star twinkling, probably you are closing the eyes too frequently. That's the only reason. Because on a clear nights, if you are able to see the stars, oftenly you are able to see one or the two stars appearing to you twinkling, others do not twinkle. So it's not that good observation that twinkle, twinkle, little stars, because all stars are not twinkling. But again, I'm appreciating the observation made by the poet. What is the first line? Star or stars? Because he is completely aware that only one or two stars you can see to be twinkling, not all. But the perception is made by everyone that stars are twinkling, so we start feeling that they are twinkling. Even though they are not appearing to us twinkling, we will say, yes, stars are twinkling. I have never seen all stars twinkling. I have seen few stars twinkling. Now, you are able to see that stars are nothing but similar to that of sun. Am I right or not? So why sun appears to us as bright and stars are not appearing to us as bright? But that cannot be the reason why it is not twinkling or why it is appearing more bright. During night, are you able to see the sun to be bright? I mean to say that sun is there close enough, but during night we are unable to see it. We are on the other side of the world where the shadow of the earth is there and that is giving us the night. True. But your logic that sun is near to us will fail in this case. Am I right or wrong? Now actually, sun is near is not the only case. You are aware of 0-watt bulb? Are you aware of 0-watt bulb? That comes in blue color, yellow color, orange color, red colors. And mostly people are using it in a dark room or a bedroom so that you have some amount of light present there. It's again a fantastic word that is coming there, 0-watt bulb. How a 0 wattage can be there for a bulb? Because if you are passing the electricity to it, how it can be 0? Yes? So what is the current flowing through it? When you are saying power is equal to 0, 220 multiplied by I will be equal to 0. So current will turn out to be 0. If no current is flowing through the bulb, then why it is glowing? That is why I said 0-watt is just a myth. It's not exactly 0-watt. It has certain amount of wattage, but the power is very less. Amount of light given by it is very less. That light is sufficient to lit a small bedroom, probably of 10 feet by 10 feet. But if I start that bulb in this hall, how it will appear to you? In the direction of the bulb, you will be able to see the light. Other part, you will be able to see that amount of darkness is more. Instead of this hall, if I construct a 5,000 square feet hall and I place the same 0-watt bulb, how it will be appearing? Only the blue color will be appearing to you, or whatever color is there, but otherwise it will be completely dark, right? So as the distance goes on increasing, all stars will be emitting the light in all possible direction, but we receive only a single ray of light. That is why they appear to us to be very small, and that is why we say that they are distant away from us. Now, if a single ray is coming from a star and the atmospheric pressures are changing, atmospheric medium is continuously changing, then refractive index of the medium will be changing. If refractive index of the medium changes, then angle of refraction will be changing. So sometimes the ray is entering our eyes, and sometimes due to the changes in the refractive index, the direction of ray is deviated away from us. It do not enter our eyes, so we start feeling that there is darkness. But next moment, again the atmosphere changes, and again you are able to see that the ray of light is entering our eyes. That is the reason we feel the twinkling effect. Are you getting? So for the stars for which you are able to see the twinkling effect, it is clear that for a moment of time, the rays are not entering your eyes. The next moment, they enter your eyes, and that is why we feel that there is a twinkling effect. Have you got the answer for that? So any other question remaining which I have started with today? Fish and the bird problem, na? Anything else other than that? Because that will require mathematics, so that is why I'm asking you. Why? Towards the earth? Are they the stars? First important thing, they are not the stars. They are asteroids. Stars are bigger than the sun, or of the size of the sun. If they appear to you to be falling, their gravity is so strong that even the earth will be dragged along with it. So only the asteroids are falling on the earth, and that lights up because of the friction of air, and that is why we feel that stars are falling, but never the star falls. Okay? Anything else? You were asking something? Okay, so should we move towards the bird and fish problem? Let's move on. U is equal to minus of? So you are considering the light coming from object or light coming from the sun? Right. No, that is our assumption so that we are able to solve the problem inconsistent with each other. Right. My question to you is, are you looking at sun or you are looking at object? Object. So the rays are finally coming from object. So you should measure the distance in the direction of ray of light coming from the object, or in the direction opposite to that of the light coming from the object. It's not about it. Suppose you are having the object here, the sun is giving the light onto this side, you are placing a mirror here. So for you, the light is traveling in this direction. So for you, the light will be traveling from left to right. Then it's accordingly, you can use the convention. The object distance will be negative. It all depends upon how the light is considered as a direction. So in the direction of measurement, you are doing it. Suppose instead of having the object and the mirror here. Mirror was here in your case, object was here. You place the mirror here. So light from the object will be coming in this direction. But from the mirror's surface, you are measuring the distance in opposite direction. So it will be negative only. I have explained you, if you consider the virtual object, yesterday also we have seen now in case of concave or convex mirror, object distance will be always negative. We have made a point, but if it is a virtual object, then you can think of a positive. So, do you agree or disagree? If you agree, say that. Okay? Okay. Now, in case of your eye, the image will be real, but it will be inverted because it is formed on the retina inside. It is not formed on the lens. Whatever you are seeing through your eyes, without a spet or with the spet, the rays are entering the lens first, and after lens, they are falling on the retina. So you have to take it on a screen. For our eyes, retina will be the screen which will be able to sense that image. It is an inverted image because we are having a convex lens. This convex lens, we are still unable to manufacture. Are you aware of this fact or not? Artificially, we cannot produce the lens of the eye. What they call it as ancillary muscles are there inside the eye, which stretches the lens and collapses the lens. So radius of curvature of that lens is changing. Due to that, you can have a focal length of the eye that could be changed. You can read it from 26 centimeter, 27 centimeter to the infinity. You can read it. This is our range. But if you try to bring it closer and closer, or you can have a book with you and see that you are touching the book to the nose and read the letters there, you will realize that you will not be able to see anything because it is out of the range. In that case, when you are bringing it very close to your eyes will be strained. If you try to read in that manner, you will start having the tears in the eyes. Your brain is sensing it right. On the retina, it is an inverted image that will be formed. But brain sense it right. Because again, the process is like this, that whatever light energy is there are what they call it as light cones. They produces the electrical signal, and this light energy is converted into the electrical energy, which is seen by the brain, not the light. Brain never sees the light. Brain senses the light because of that conversion of light energy into the electrical energy. Okay? So there is some biological aspect involved in it, which we call it as a particular type of eyesight. That could be helpful to you to understand the terms of parallax. When you are looking through one eye, closing one eye, your position appears to me to the right. When I put it down, close this eye and observe you, you appears to me to the left. We are having what they call, I'm not getting exactly the word, I know that word, but I'm not getting that word. You are having a vision which will be able to see you the depth. This type of vision by two eyes, we are able to feel the depth. Like, there is one simple experiment that could be done. Place a glass at the end, okay, and ask the person to close one eye and try to put the marble into it. It will be difficult for him because he doesn't have the understanding of the depth. We have this type of a vision, I think it is called as binocular vision, because of which we are able to get the idea of the depth. Otherwise, it is very difficult. By two eyes, we get the idea of the depth. By one eye, we don't get the idea of the depth. And if the idea of the depth is known, then we can have a proper understanding. Suppose I ask you to throw the ball. Then where it is to be thrown, that requires a three-dimensional depth. Right? If one eye is closed, you will not be able to judge that. That is the reason. But only human beings have that. Other, like many of the, what I can say, birds, they have a different type of vision. They can see only in this particular part or in this particular part. They cannot focus it directly in the front. There are certain birds there. So it depends. Biologically, it depends. Okay, so should we move ahead now? Now, actually, our problem is we want to try to understand the kingfisher or a bird which hunts the fish is looking at the fish from the sky into the water. So the situation would appear to you like this. You are having here water whose refractive index of water is mu w. Definitely, I will be able to show a fish here. This is a fish inside the water. It is present at an actual depth. We call it as d actual. Able to get this? You are having here air medium whose refractive index is taken as refractive index of air, and you will be able to have somewhere here the bird. This is a symbolic form of a bird. I am not drawing it bigger. Right? Now, how the light will be traveling is the first important case. How the light will be traveling. It should travel from fish to bird because bird is watching the fish. So the light will start from the denser medium and will strike at this point. This is representing the angle of incidence. Am I right? And the ray, instead of traveling along a straight line here, it is traveling from denser to the rarer medium. As it is traveling from denser to the rarer medium, the ray will be bending away from the normal and will be reaching to the bird. This is your angle of refraction. And you are able to see that this is representing the angle of deviation. It has moved away from the normal. Am I right? The ray was originally passing along this direction, or this one is the angle of deviation. Sorry. This one will be the angle of deviation, right? Okay? ठीक है यहाँ पर? Now in this case, what is the basic property? The light travels in a... So the bird do not feel the fish to be present here. It feels that the light is coming from this position here. And the fish appears to the bird to be like this, somewhat like this. This is what we call it as de-apparent. So the bird watching a fish is at a greater depth, and you are able to see that bird feels that the fish is closer to the surface. So automatically the bird gets an advantage to feel that it can easily catch the prey. Are you getting this part? Now here we have to make the use of mathematics. If this angle is R, can I mark this angle as R? Right? If I drop a straight line to form a right angle triangle, if I drop a straight line to form a right angle triangle here, like this, okay, then this is right angle triangle. Can I mark this angle as R? And can I mark this angle as I? Can I mark the angle as I? I'm using the basic properties of parallel lines to mark all these things. Can I mark it? Yes or no? So let me label the positions here. I'll be calling this as point A, this as point B, this point as C, and this point as D. So in this case, in triangle, I'll be able to call it as CAB. In triangle CAB, I will be having here sine of R is approximately equal to tan of R is approximately equal to opposite side AB divided by the adjacent side, that is taken as D apparent. Can I use this relation? Under what condition I can use this relation? Sin R is approximately equal to tan R. Have I talked about it on a very first day? Given you the proof on the second day? You were bringing the log tables with you. Limit theta tending to 0, sin theta upon theta is 1. Limit theta tending to 0, tan theta upon theta is 1. So sin theta will be approximately equal to tan theta is equal to theta. Theta is, in this case, tan theta is opposite side upon adjacent side. So can I write down AB upon DAP? That is the apparent depth, because I have considered the triangle CAB. Now if I consider the triangle DAB, in triangle DAB, you will be able to write down sine of I is equal to, approximately equal to tan of I, approximately equal to tan I will be AB, again the opposite side, upon D actual. Correct? Then I can work with this relation, refractive index of the water multiplied by sine of I is equal to refractive index of air multiplied by sine of R. Can I write down like this? Now from the above relation, I will be having refractive index of water into sine of I, that is AB divided by D actual is equal to refractive index of air multiplied by sine of R, that is AB upon D apparent. The factor AB is getting cancelled throughout. So you will be having refractive index of water with respect to refractive index of air is equal to D actual upon D apparent. So I can rewrite here refractive index of water with respect to air is equal to D actual upon D apparent. Number? Today's 25. Right? I can put it down this relation as refractive index of water with respect to air minus of 1 is equal to D actual minus of D apparent divided by D apparent. I can rewrite this as change in the depth. Change in depth will be taken as, this will be refractive index of water with respect to air minus of 1 multiplied by D apparent. Getting the form? Then I can rewrite this relation as the change in depth will be taken as change in depth का मतलब समझ रहे हो ना, ये वाला distance मैं निकाल रहा हूं. This is the distance I am looking at. This is representing the change in depth. क्योंकि जो D actual है और जो D apparent है उनमें का difference निकाल रहा हूं. यानी I am determining this particular part here, right? So if you want to put it down, I will be having D apparent. So you will be able to write down here D actual into bracket 1 minus 1 upon refractive index of water with respect to air. Getting the mathematics? So birds are able to see the fishes more closer to the surface. And now the question arises how the fish will see the bird. Right? So in that case, how the figure will change now? The light will be coming from bird and it will be entering the eyes of the fish. Again, there is a change of medium. And if there is a change of medium, how that will appear? Can you draw the figure now? Try to draw the figure now. And see what exactly happens. With this background, you should be able to draw that figure and then we will be able to talk in terms of it. Because actually in this case, we will not be talking about depth now. We will be talking about the height of the bird above that water. Able to get it? And how the fish will see that bird. Whether the bird will start feeling that the fish will start feeling that the bird is closer to the water or bird is away from the water, that we have to find it out. Okay? So just draw the figure, then I'll explain you the whole part again. You are having a water with refractive index mu w and you are having air present here with a refractive index mu a. The bird would be appearing to you like this. The ray of light will be traveling from bird in this direction. It will be incident on the boundary of the medium of air and water. You will be able to see that this will be a normal drawn. This is representing to you the angle of incidence. The ray is expected to travel along a straight line here inside the water, but as it is traveling from rarer to denser, it will be bending towards the normal. So you will be able to show that this is bending towards the normal. This is representing the angle of refraction. Okay? Getting it? Now, you will be able to see that this is the actual height. I will be able to put down this height above the boundary as h actual. And here, the fish should be present here. Which should be receiving the light. Okay? So for this particular fish, the light travels in a straight line. So the light would appear to the fish to be coming from this position up to above. So the apparent height here for the bird would appear to you like this, h apparent. Because light travels in a straight line. So the fish will find that the bird is flying much more above its actual height. Okay? Now again we can work with this part. Angle of incidence has been marked here. So if I consider this triangle as O, A and B, so this is a right angle and this is I, so this will be also I here. Am I right? Right or not? Angle of incidence आपका ये है, ये दो लाइंस पैरेलल है, ये इंटरसेप्ट हो गया तो ये ऑल्टरनेट एंगल बन गया ना. Okay? Now if I consider the other part of it, this is angle R. ये वाला एंगल आप R मार्क कर रहे हो, तो इसका अपोजिट एंगल कौन सा रहेगा? ये वाला एंगल R रहेगा, ये वाला एंगल R रहेगा आपका. Opposite angle. Now, if this is the opposite angle and I am again drawing a straight line like this, actually I have to go beyond the board, but if you assume it to be a right angle triangle, then this angle will be R here. Right? Now, if this is so, I will be again making the relation same way. You will be having refractive index in a air multiplied by sine of I is equal to refractive index in a water multiplied by sine of R. Now, sine I, you are aware of the fact, is approximately equal to tan of I, is approximately equal to tan of I लिया है हमने, तो you will be having opposite side OA divided by adjacent side, that will be H actual, and you will be having sine of R approximately equal to tan of R approximately equal to OA upon H apparent. So if you substitute it here, refractive index of air multiplied by sine I, that is OA upon H actual, is equal to refractive index of water into sine of R, OA divided by H apparent. The factor OA is getting cancelled. You will be able to write down here H apparent upon H actual is equal to refractive index of water upon refractive index of air, that is equal to refractive index of water with respect to air. Your number would be further increasing this to 28. Right? So apparent change in height can be calculated again. So apparent change in height will be this difference of height that we are looking at here. So how much will be that difference in height? So you will be having H apparent minus of H actual divided by H actual is equal to refractive index of water with respect to air minus of 1. So change in the height would appear to you as H actual into refractive index of water with respect to air minus of 1, or it will be H apparent multiplied by 1 minus 1 upon refractive index of water with respect to air. So you can add to the list here. The formula would be around 29 or 30. 29, this will be 30. So what is bird feeling? Fish is closer to the surface. And what is fish feeling? So even if the fish is closer to the surface, the fish starts feeling that bird is still away. And that is why it gets the courage to swim to the top. Because it is having the feeling that bird is away. But bird feels that fish is closer. And actually the fish is closer. So bird is able to pick up the fish from the water. That is why nature helps bird rather than fishes. Able to get this part? Getting the analysis, the mathematics behind it? This formula will be useful to you to get the answers directly for the objectives. There are right angle triangles. You have to extend it beyond the board, then you will be able to get a right angle triangle. Angle R is present here. No, this is the angle R. And this is the straight line. So they are becoming alternate angles. Should I rub off? Should I clear this? Now, we are having one more concept that is to be seen. Right down there. For a given thickness of a medium, for a given thickness of a medium, normal shift is independent of position of object. Normal shift is independent of position of object. Position of object, and depends only on the thickness and nature of medium and nature of medium. Thickness and nature of medium. Consider this to be a glass medium whose refractive index of glass with respect to the air is like this. We assume here that there is an object O, and this object is making the ray of light incident onto the surface here. This medium is air, right? This is a glass. At the point of incidence, we will be calling this as angle of incidence, right? How will be the ray traveling? How will be the ray traveling? It is moving from rarer to the denser medium. So how it will be traveling? It will be traveling towards the normal. So you will be able to show that it will be traveling and bending along this direction. Okay? And at this particular point, it will be bending away from the normal because it is moving back into the air. So this is representing to you angle of refraction. This is also representing to you the same angle. Same angle will be there. One is angle of refraction, but at the other point it will become angle of incidence. Okay? Getting it? Now actually you will be able to see that the final ray is emerging out along this direction. So if I stretch it back, this will be the straight line as if the light will be coming from the straight line here. Right? So you will be able to see that the image is formed on this side. This is the image direction that you will be able to see it here. Now from this part you will be able to drop up perpendiculars or the perpendicular lines. You will be able to see that the shift in the normal direction, that will be vertical shift. True or false? Shift कितना हो रहा है? So suppose I call this point as again O dash. And from here, if I draw the line vertically like this, then this point here will be called as I dash. And if I consider the line from here to here, this is again I. This is the line of I. So are these equal distances or different distances? Check it out because the lines are parallel. नॉर्मल शिफ्ट यानी वर्टिकल शिफ्ट की मैं बात कर रहा हूं. द रे हैज शिफ्टेड वर्टिकली अपवर्ड. ये हमारा ओरिजिनल रे है. इमेज से देखोगे तो ये रे दिखाई दे रहा है हमें. तो नॉर्मली या ऊपर के डायरेक्शन में कितना शिफ्ट हुआ? OI हुआ है. अगर ये पॉइंट पे भी देखोगे तो शिफ्ट विल बी ऑफ द सेम वैल्यू. आर यू गेटिंग इट? सो दिस इज कॉल्ड एज नॉर्मल शिफ्ट. जैसे अभी तक हमने बर्ड के केस में और फिश के केस में देखा था, दैट वाज नॉर्मल शिफ्ट because the fish was appearing to you to be vertically up. Am I right or wrong? Right? But there is also a lateral shift along the horizontal direction. So if you look at that part, if I consider this as a right angle triangle, then you are able to see that there is some lateral shift, horizontal shift हुआ है ना पोजीशन का. ये पॉइंट O है मेरा, यहां का पॉइंट यहां पर है, तो ये लैटरली शिफ्ट हुआ या नहीं? हॉरिजॉन्टली शिफ्ट हुआ है ना ये. सो देयर आर टू टर्म्स हियर. वन इज कॉल्ड नॉर्मल शिफ्ट, अनदर वन इज कॉल्ड हॉरिजॉन्टल शिफ्ट और लैटरल शिफ्ट. तो ये नॉर्मल शिफ्ट कितना होता है? दैट वी हैव सीन इन अर्लियर एक्सप्रेशंस. व्हाट इज द चेंज इन डेप्थ का फॉर्मूला पता है? चेंज इन डेप्थ फॉर द फिशेस निकाला था. डी apparent किया था ना वो, बराबर है या नहीं? सो वी कैन यूज द सेम फॉर्मूला फॉर द नॉर्मल शिफ्ट हियर. सो मेंशन द फॉर्मूला. नॉर्मल शिफ्ट is equal to 1 minus 1 by mu multiplied by thickness of the glass slab. सेम फॉर्मूला है वो, बिकॉज वी आर टेकिंग थिकनेस, तो हमने वो वाला फॉर्मूला लिया है. 1 minus 1 upon refractive index multiplied by thickness of the glass slab. That is giving us the value of normal shift. Lateral shift is given by y is equal to normal shift multiplied by sine of angle of incidence. Now suppose you are having two layers of liquid and at the bottom of the container there is a point object. Then what will be the formula for the refractive index of the two liquids taken together? So let us put down that problem here. First in the problem we will be putting a figure. This is representing to you depth of the first liquid D1. There is another liquid here whose depth is different and is taken as equal to D2. This is the actual depth that we are having. We are having the object present at this point. This is the object. So the ray of light will be starting from the object and it will be moving straight up to this particular part of the boundary of the two media. This is having the refractive index mu1. This is having the refractive index mu2. So the ray will be traveling from O to the boundary here. At this point, you will be able to mark the angle of incidence. Okay. This is representing to you angle of incidence here. I will be able to have the refraction taking place at this point. The ray, instead of traveling along a straight line here, it will be bending. It will depend upon the relation between mu1 and mu2. बराबर है या नहीं है? Which one is rarer and which one is denser? What do you think? You are having two immiscible liquids of refractive index mu1 and mu2. Which one will be denser and which one will be rarer? Water कहाँ लिखा है मैंने? At the bottom it will be denser and at the top it will be a rarer, because rarer liquids will be floating on the denser liquid. Am I right? So you will be taking here the refractive index of first greater than refractive index of 2, then only the lighter liquid or a rarer liquid will be able to float on a denser liquid. So it is traveling from denser to the rarer. In what direction it should move? Away from the normal. So I will be able to show that this will be appearing to you to be moving away from the normal. Okay? So you will be able to stretch it back because the light will appear to you to be coming from this particular point. This will be called as image eye. Able to get it? You are able to call this angle as an angle of refraction here. And then it will be moving again. This will be your, you will be getting here this as angle of refraction only. That is angle of incidence at the top layer. And then it will be moving out. Instead of traveling along a straight line, it will be traveling somewhere here. That is the reason why I stretch it back. I will be able to have this as the second image that would be formed here. So what is the actual depth of the two liquids? So I will be able to write down here D actual will be equal to D1 plus D2. Let me call it as equation A. This will be the actual depth. And what will be the apparent depth? That is to be calculated, because for the first refraction, the apparent depth would be like this only. So how do we calculate that? Remembering the part? We are using the relation sine of theta approximately equal to tan of theta approximately equal to theta. Remembering it? So if I consider this to be angle I and draw a straight line here to form a triangle, can I call this as I? Can I call it as I? And similarly, this will be your corresponding angle R. These two are parallel lines. There will be corresponding angles then. Right? So again, you will be using this relation and you will be writing here, suppose this O is there. This is the apparent depth that we are looking for the first part. D1 is the actual depth. This is apparent depth. So you will be having the apparent depth. I'll be writing it as D apparent 1. D apparent 1 is this part here. Again, you use the right angle triangle property. If I call this as the length AB sidewise, tan of I will be equal to AB upon D1. So tan of I is approximately equal to sine of I is approximately equal to AB upon I. AB upon, you will be having here D1 sin I के लिए. Similarly, you will be having tan of R approximately equal to sine of r, approximately equal to AB will be there, divided by D apparent 1. हमने अभी देखा है ना इसको. I'm just repeating the steps. So if you add it, what you will have? You will be writing here mu1 multiplied by sine of I1, sine of I, that is taken as AB upon D1. AB upon D1 is equal to mu2 into AB upon D apparent 1. So AB is getting cancelled. You will be having refractive index of 1 upon refractive index of 2. That is equal to D1 upon D apparent 1. Refractive index, this one. R is here, no? So this R, I am taking it here. So for this, these are equilateral triangles again, wo. So from that, I am able to write down. I am not doing it for the first time. I have done it minimum 2 times earlier. So I am just telling you what you will be having. Now actually for the second part, you will be having the D apparent to be calculated. So second part, D apparent 2 will be equal to D1 plus D apparent 2. D apparent will be there. ये देखिए यहां पर मैं बता रहा हूं आपको अभी, ये जो डिस्टेंस है वो कितना लेना पड़ेगा आपको. ये एक्चुअली आपका यही डेप्थ आएगा ना, ये वाला आएगा. ये आपका डी apparent 2 आएगा ना. दिस इज डी apparent 2. सो वो D1 प्लस ये डिफरेंस आएगा ना दोनों के बीच में. So you can directly go for D apparent 2 on the same lines. This will be another angle here. ये angle of incidence same होता है, ये इसको मैं angle of emergence बोल रहा हूं. So I will be able to mark this angle as E. You are having R here, so I can take this as also R. So ये वाला भी मेरा angle R होगा. तो ये मेरा ट्रायंगल इस तरह से बन रहा है यहां पर. और एक ट्रायंगल यहां पर बन रहा है इस तरह से. So I will be able to write down this as C and D, and I will be having here tan of CD E is approximately equal to sine of E, and that will be taken as equal to opposite side CD divided by D apparent 2. And you will be having here tan of R approximately equal to sine of R, approximately equal to, that will be CD upon, you will be able to have D2 plus some factor here. ये डिस्टेंस लेना है आपको यहां से यहां तक का. ये कितना आएगा? कितना आएगा ये डिस्टेंस? Because this part is D2, this is D1. So you will be having D1 तो यहां तक आ गया, और फिर बाद में आपको इतना पोर्शन माइनस करना पड़ेगा ना उसमें से. I can put it as D2 plus देखो ये वाला डिस्टेंस कितना है यहां से यहां तक का, दैट इज डी अपैरेंट 1, बराबर है या नहीं? दिस इज डी अपैरेंट 1, यहां से यहां तक का जो डिस्टेंस है दैट इज डी अपैरेंट 1, और ये जो है दैट इज डी अपैरेंट 2 है. Okay, so when you want to find out this distance, you will be having the total distance to be taken as d1 d1 plus d2 minus कुछ आ रहा है क्या? So now I've written the part, check it out, otherwise I'll explain. Now actually what is happening, let's begin from the start. We are having the object present here, right? The ray of light is incident at this point. It is traveling from denser to the rarer, so it is bending away from the normal. Okay? This is called angle of incidence, so this will be your angle of refraction. Angle of incidence is here. If I construct a right angle triangle here, then this angle will also be the angle of incidence. Right? Now, if I consider this as angle of incidence, then for this corresponding angle for R would be like this, and there will be a smaller triangle that will be formed here with this as angle R. Now we are using this concept that tan of I is approximately equal to sin of I is equal to AB upon D1. You can check it out. Sin I is present here. This is angle I. So sin I will be opposite side upon adjacent side, that is D1. That is why it is written here AB upon D1. Okay? Then it is written tan R is approximately equal to sin R. Now this is tan R. For this triangle tan R, AB upon this particular part will be the apparent depth 1. Because the depth is taken from surface in a downward direction, so it is D apparent 1. Okay? Now using this, I am able to derive this. Mu1 upon mu2 is equal to D1 upon D apparent 1. From this, I can write down mu2 upon mu1 is equal to D apparent 1 upon D1. So D apparent 1 is mu2 by mu1 into D1. Okay, up to this part. यानी जो नीचे का पार्ट है वो तो क्लियर है. अब हम क्या करते हैं कि रे यहां पर इंसिडेंट हो रहा है, तो दिस इज बिकमिंग एंगल ऑफ इंसिडेंस विच इज इक्वल टू दिस वन. ये दोनों इक्वल रहते हैं क्योंकि द रे इज इन द सेम मीडियम. जो एंगल ऑफ रिफ्रैक्शन यहां रहेगा वो एंगल ऑफ इंसिडेंस रहेगा. रिफ्रैक्ट होने के बाद मैंने एंगल लिखा एंगल ऑफ इमर्जेंस. So if you compare, angle of emergence will be here, angle of emergence will be here, they are corresponding angles. Similarly, angle R is present here, angle R is present here. Now, for me, if I use sine of E, that is equal to tan of E, opposite side will be here, that is equal to upon D apparent 2. Am I right or wrong? And then I am using tan of R is equal to sine of R. So sine of R will be taken as CD upon this part. This part will be there. So that will be comprising of D2 plus this part of apparent depth. That is D apparent 1, mu2 upon mu1 into D1. That is why I'm able to write down like this. Getting it now? Now from this you are able to derive that relation. इससे हम क्या कर पाएंगे? You will be able to write down here the same way as we have done in the first case. You will be able to have mu2 into R. So you will be having mu2 multiplied by sine of R. So that is equal to CD divided by D2 plus mu2 by mu1 into D1 is equal to, on this side, what you will have? It will be 1 only because it's a air that we are putting it, multiplied by sine of E. Sine of E will be there. So sine of E will be how much? CD upon D apparent 2. So the factor CD is getting cancelled here, and you will be able to write down this as D apparent 2 will be equal to, you will be having this as D2 plus mu2 by mu1 into D1 whole divided by mu2. Right? So I will be able to write down D apparent 2 will be equal to, can I put down this relation as D2 upon mu2 plus D1 upon mu1? So what will be D actual upon D apparent? D1 plus D2 upon. So you will be able to write down D actual upon D apparent. That ratio will be taken as D1 plus D2, that is the D actual, divided by D1 upon mu1 plus D2 upon mu2. Can you write down this? D1 plus D2 is D actual. D apparent 2 is given by this formula. So you will be having this as a refractive index. This will be refractive index now. It is the light traveling from mu1 to mu2. So you will be writing this as refractive index of second liquid with respect to first. So this is actually the refractive index for multiple layers of the liquid. Right? अब ये हमारे वैसे एनसीईआरटी के सिलेबस में नहीं है, but NEET के हिसाब से that point has been covered here. Okay? So this is all about the refraction which we have covered here. It's purely the case of refraction. So this is the formula for refractive index of second medium with respect to the first. That is given by D1 plus D2 upon D1 by mu1 plus D2 by mu2. This is your formula number that should be given there. There is this last concept that is remaining, that is total internal reflection. So we'll cover that part and then move on to the problems. We'll try to solve as much as problems as we can, because yesterday I was going to start with the problems today, but sir would have got bored a lot because he wanted to attend that lecture, so I started with a new concept. In problem solving, he would not be doing anything as such. Okay? So are you aware of total internal reflection? What is that? Now, we are having a denser medium present here, whose refractive index is mu d. You are having a rarer medium present here, whose refractive index is mu r. The source of light is present here. This is representing the source of light. In which direction the source will be emitting the light? In which direction the source will be emitting the light? In which direction it will be emitting the light? All directions. Can I consider it? So I can consider here the first ray of light coming normally and incident here. What will be the angle of incidence? So what will be the angle of refraction? So will there be a refraction that will be taking place here? So ray will be passing vertically up without deviation. If I consider another ray and make it incident here, then you will find that this will be the angle of incidence. And the ray, instead of traveling along a straight line here, it will be moving from denser to rarer, so it will be bending away from the normal. If I consider the third ray is incident at this point. Angle of incidence has increased. Let me call this as I1. So I will be able to call this as I2, and I will be able to write down the value of I2 is greater than I1. Then you will find that the ray, instead of traveling along a straight line here, it will be bending away from the normal. If this is representing R1, then this is representing R2. In this case, the value of R2 is greater than R1. Right? If I consider the third ray that is traveling and incident here, what is happening to the angle of incidence? It is further increasing. So let me call this as I3. Again, I will be able to put down here I3 greater than I2 greater than I1. Now, in this case, the ray was assumed to be traveling along a straight line here, but it is bending along this direction, giving rise to the R3 value. The value of R3 is going to be greater than R2 greater than R1. Now, if I make it incident at a particular angle here, this angle of incidence, we call it as I4, or we denote it by C, for which the ray of light appears to be traveling parallel to the surface of the water. So that angle of refraction R4 is becoming 90 degree. Then the ray of light at the angle of incidence, for which the ray of refraction is making 90 degree, such a incident angle, we call it as critical angle. That is why we call it as C. C is standing for critical angle here. Critical angle. Critical angle is that angle of incidence for which the refracted ray will be traveling parallel to the surface of the water. Angle of refraction will be 90 degree, then that angle of incidence is called as critical angle. We can calculate the relation of refractive index. We can put it down here. Refractive index of a denser medium multiplied by sine of critical angle is equal to refractive index of rarer medium multiplied by sine of 90 degree. Why sine of 90 degree? I am making the use of Snell's law here. So if you solve it, you will be able to write down sine of critical angle is taken as refractive index of rarer upon refractive index of denser. This could be written as 1 upon refractive index of denser upon refractive index of rarer. This will be 1 upon refractive index of denser with respect to the rarer. So this is giving you your new formula for the critical angle. Number, you can check it out. Okay? Now, if suppose you are having the light incident with an angle greater than critical angle. So I am having now a light traveling along this direction and hitting the surface here. So in this case, is your angle of incidence greater than C? This angle of incidence I, is it greater than angle of incidence C? So you are having I greater than C, then you will find that there will be no refraction. There will be no refraction. But there will be a reflection taking place and the ray will suffer the reflection with this angle I equal to the angle of reflection here. So the ray, instead of traveling from denser to rarer medium, it is remaining in the denser medium itself, and that is why we call it as total internal reflection. Got this concept? So for that, sign of critical angle should be 1 upon refractive index of denser medium with respect to the rarer medium. Okay? Now you should make a table here, because that table will always help you to get the answer as a ready reckoner. Because we are having refractive index of denser with respect to rarer, I can think of refractive index of glass with respect to air, that is equal to 1.5. Refractive index of water with respect to air, that is 1.33. Refractive index of diamond with respect to air, that is equal to 2.1. Right? Any other you can calculate or aware of? I can also calculate refractive index of glass with respect to water is equal to refractive index of water with respect to glass with respect to air divided by refractive index of water with respect to air. So glass is taken as 3/2 divided by 4/3. So you will be having 9/8. So I can take here refractive index of glass with respect to water as equal to 9/8. Can you find the critical angle for all these things? So you can have here refractive index is known to you. So what will be 1 upon 3/2? 1 upon refractive index कितना आएगा यहाँ पर? 1 upon 3/2 will be 2/3. So this is giving me 2/3. This is 4/3. So this will be 3/4. This will be giving me the value as 1 upon 2.1. So it will be 0.5 के पास आएगा 1 upon 2.1. And this will be 8/9. And this is equal to sign of critical angle. So can you calculate the critical angle for all these material? निकाल के रख दीजिए. ऑब्जेक्टिव में इस तरह का क्वेश्चन आता है तो डायरेक्टली आंसर याद होगा तो मार्क करके आगे बढ़ सकते हो. That is why I have to make a table. You have to find out sign of critical angle. This is equal to sign of critical angle. And from that you find out the critical angle, fill up these values. Critical angle will be sine inverse of 2/3 here. Sine inverse of 2/3. This will be sine inverse of 3/4. Calculate the exact value. Sine inverse of 1 upon 2.1. Then sine inverse of 8/9. निकाल के रख दो. Now, if you remember one more important thing that you can work for the sign of critical angle. Sign of critical angle is taken as 1 upon refractive index of denser medium with respect to rarer. This is taken as equal to 1 upon velocity in a rarer medium upon velocity in a denser medium. So this will be giving me velocity in denser medium upon velocity in rarer medium. Can I put down this relation, sine of critical angle? लिख सकते हैं क्या? Come on, say something. Can I write down like this? Yes or no? So you can put it down here, this to be equal to frequency into lambda in denser medium upon velocity in a rarer medium. So sine of critical angle is directly proportional to lambda in a denser medium. Am I right? So greater is the value of lambda d, greater is the value of wavelength in a denser medium, greater will be the sine of critical angle, greater is the value of sine of critical angle will be greater. So can you tell me which wavelength will have more critical angle? Red will be having the more critical angle. That is why this relation has been given to you. Now this completes your total internal reflection. It's not big, it's a small topic there. कितने हो गए? 87. So 13 बाकी है. Century complete करना है ना? But this is true in every chapter, huh? I don't know how much you have worked for the other chapter. I derived around 128 formulae in gravitation. So in every chapter you will be having up to above 100 only the formulae, except for semiconductors, except for electromagnetic waves. But most of the chapters will be having number of formulas extremely large. And number of formulas are nothing but the different mathematical conditions which we are looking at. And that is the reason why I am asking you that you need to work on it. Okay? So without putting the effort, you will not be able to get the analysis there. It's very simple. If you have gone through all these conditions well, then you can handle any problem easily. Because you have seen the situation. Just imagine you have never seen such different formulae and you are facing a problem, then at the last moment it will be difficult for you to derive the same. But if you have seen it once, handle similar problems, then it will be easy for you to proceed ahead. Okay? So let us take some problems here, which we have left out yesterday. कल एक प्रॉब्लम दिया था जाने के पहले, तो वो आ गया था या नहीं आया था? Because few students have got the answer yesterday only. They have given the answer as minus 20 centimeter. आ गया था वो? Good. Now write down a problem. Now again we are referring back to concave mirror, convex mirror. बोलो. Actually, I didn't have any issue because they have told me that when they will be calling me from outside, then only I should leave. So if you want a bio break, you can take it, no problem. Any moment. Okay. An object is placed at right angles. An object is placed at right angles to the principal axis of a concave mirror at a distance of 30 centimeter from the pole. 30 centimeter from the pole. And the image formed is real and twice the size of the object. Find another position of the object. Find another position of the object such that size of image will be again twice the size of object. So I'm giving you exactly 5 minutes to complete that. See whether you are able to think on the basis of the yesterday's lecture. I think you should be able to get the answer. It's not difficult one, it's a simple one. Even if you don't get it, just try to look at the solution, you will get it next time. But your attempt is very much required.